console. You can access those consoles using Control-Alt F1 through F5. The consoles provide invaluable information regarding the detection of hardware and the installation of software. So there's one screen which keeps a running log of what's being installed, what's being done to the system, including individual commands that are being executed by the installer. There's another screen which is responsible for hardware detection, the status of hardware detection, which includes the processors, memory, storage, network, audio, CD-ROMs, DVD drives, writers, you name it. Anything that's attached to your system that Linux supports or even doesn't support will be enumerated on the hardware detection screen and can provide invaluable information to you in the event that there's a problem. And even if there's no problem, just for your own edification. So we're at the halfway point with the dependencies. Now you will notice that on VMware the performance is a little bit slower than a native computer, and in some cases it may be much, much slower, depending on the utilization of the system. Now remember, when you install within a VMware environment, you're making use of emulation. So it's not a real computer, it's a software-presented computer. So although it's fast, it's not as fast and will never be as fast as a comparable physical computer. However, it may be fast enough for your intents and purposes. For example, for simple services like DHCP and DNS, NTP and FTP, SSH, Telnet, and others, it may make sense to install those systems within a contained VMware setting on one physical system, whereas more complex taxing systems like web, databases, and application servers will benefit from dedicated physical hardware. Or you can build your systems vertically by building bigger systems with more CPUs, more hard drives, more and faster hard drives, great network connectivity, and simply cut up the resources using software like VMware. The version of VMware that we're using is the Server Edition, which is free. It's open source and you can download it and use it within your environment. But if you want a full management framework, you'll need to look at the ESX or full VMware management suite of applications. Now just like before, the installation process will create an install.log file in root, which will serve as our proof as to what the installation program did and didn't do. It will also create a kickstart file, anaconda-ks.cfg, in the /root directory, which can be used to replicate this installation on this or other machines. Because the file system is much smaller than the server that we installed on, which had to allocate about 100 gigabytes for the root file system, this has been formatted much, much quicker. Again, the allocation of file systems using ext3, riser, and other file system types like JFS, XFS, etc. tends to take a good amount of time. Formatting also takes some time, so you just have to wait it out. Now the image is being transferred. It'll be on the hard drive momentarily, at which point the files will begin copying, as you can see here in the background. So this installation is proceeding much, much faster. Now this system isn't considerably faster than the Dell PowerEdge server. Each processor is about 200 megahertz faster. That's it. Not much of a difference. They're comparable, in fact. At any time, you can interact with the virtual machines by selecting options that are not grayed out, such as power off, suspend, etc. up top. You can also navigate back to your shell and other programs while the virtual machine is installed. Again, the files haven't been copied yet, so it's going to take a while, and we're going to catch up to it at the beginning, middle, and end sections and just ensure that the system reboots into a full environment. Now it's preparing the transaction from installation source, ensuring that the disk has the options or the different packages that are necessary to fulfill our options. And now you see the packages being copied. The G library, or glibc that is, C library. We get an ETA below. So the estimation is roughly 1 minute or 1 hour, 9 minutes, 27 seconds for the full installation, which seems about right, but it's variable. It's subject to change. In total, we'll install just under 950 packages. And again, there are thousands included with this release of Red Hat Enterprise, just as you'd find with other Linux distros. So now we're down to 14 minutes as opposed to over an hour, and this is more like it. So these packages will be copied very quickly off the DVD. We won't be prompted for additional media since we have everything in one place. Again, when you sign up for a subscription or for a trial at redhat.com, you'll be provided with login access and the ability to download the CDs and or DVDs for the latest release of Red Hat Enterprise, as well as for older releases such as 2.1, 3, and 4, which are still used quite heavily in the wild. So the current ETA is 13 minutes. We'll catch up to it at roughly the halfway point and then go through the full reboot. So now we're ending the installation at 96%. We should be ready momentarily to reboot and enter the new system. Now, if we have problems launching in graphical mode, we can always change the run level to the text mode of run level 3, which will ensure that all background services run or while avoiding the problems associated with starting up in a graphical environment within VMware. Again, you're likely to experience this sort of problem even on a native system, as the kernel and the installer doesn't always detect the connected hardware. So it's just a fact of life when working with Linux, but when installing a server, it's less important or a non-issue, as the purpose of the server is to serve or to provide background services and not necessarily a desktop. So just like in the graphical mode, performing a post-install configuration is taking place. And again, the consoles are available, which provide information, and install.log is made available in root's home directory beneath /root, so that once you're up and running, you can peruse it to determine if there are problems, or just to see what was detected and what transpired on your system. So the installation is complete. We should remove any media and reboot the system to get it to boot into the operating system. So let's go ahead and eject the media. And if you're following along, you would have seen that the installer has already ejected the media for you. So we'll enter to reboot, and the system will be rebooted momentarily. These are some of the items we didn't see when we were installing from the console, such as the unmount of the file system. And here's the boot menu, at which point we can interact with it by pressing enter, but it prompts for only a few seconds, so you have to interact with it very quickly. ACPI, 2 logical volumes found, one for swap, the other for the root file system. If you recall, we discussed that during installation. You can interact with the installation at this point by pressing I, and you can use it to interact with the loading of each of the services, but you have to do it at that point. So in other words, you have to do it very quickly. The file systems have come up, including boot and the root file system. It entered run level number 3, which means it should load different services. As you can see, IP6 tables, firewall rules were loaded. SSH version 1 and 2 RSA and DSA keys are being generated or have been generated. Cups started, SendMail, the default SMTP application, and here we are again with text, or a text-based interface. So select the item that you wish to modify. You can pick whichever option you like, such as a firewall configuration. We'll tell it to disable the firewall like we did previously. SE Linux will tell it to use the disabled mode, which means it will simply complain if there are problems. There are other options: network configuration, which we have set to DHCP, various system services, the time zone configuration, enter to run the tool, It's set to America, New York, which was determined during the installation. Keyboard configuration, authentication, whether or not you want to authenticate against a remote source. Now our system's up and running. There it is. We have a login prompt. We can log in. Let's say as a user root, and we have a shell. If we type TTY, you'll see that we're on the first teletype terminal. We can interact with the other terminals using Control-Alt F1 through F6. We can take a look at the disks or the file system by using df-h, where we see that of the 8 gigabytes, 6.7 were allocated to the root file system, 100 megabytes were allocated to the boot file system, TempFS has 252 megabytes, and the swap file system has its item. Let's just list here. Let's swap on. And it has its items list, swap on -s, that is. So the swap file system is set to be at about a gigabyte size, being 104,856.8 in kilobytes, of course. So we're up and running. Top will tell us what's there and how much of the CPU is being utilized. Netstat will tell us what services are bound, which includes ports 910 and 111 for RPC services, 631 for CUPS, 25 for SMTP. NTLP will tell us the programs that are attached to those ports, SSH being on port 22, and we're up ready to access connection. Sendmail is listening on port 25, and Netstat NUL will return any UDP listeners, including DHCP, CUPS, among others. And an if config will tell us the configuration. As you can see, we got an IP address of .199 from the DHCP server. We should be able to ping out, sending 3 packets to the default gateway, and it responds indicating that this system is properly connected to the network. The IP version 6 prefix was also configured, 6-4 prefix of 2002-4687 DB25. We're on the 3rd network, followed by the embedded MAC address of the local system, constituting a 128-bit unique IPv6 address. So IPv6 is configured, IPv4 is configured. Our interface is up and running. We can communicate, and we can use the system in run level 3. By the way, if we type run level, it'll tell us what run level we're in. We're in 3 because we were unable to configure the X environment during installation. So rather than attempt to enter a misconfigured X environment, the Red Hat installer simply defaults to run level number 3. That's it. We have a new host up and running. Host name tells us that we can exit. It returns us to TTY1, and in this case it's Enterprise Linux Server Release 5.1. The latest patch is available, and it's using the 2.6.18 kernel. So we're up and running. This is a VMware instance, which is independent of everything else. We can use the system, access it from the wire, all without using an additional physical system. Now we want to look at other installation methods, including Anaconda and network-based installations. So we'll be focusing on those items.